Hi there. This is my first of my series of videos where I'll be trying to explain how computers work. And as you know, computers or any electronic devices, they are powered by electricity. And we'll start off with a basic understanding of what electricity is and how it powers the computers. Now, to understand electricity, probably the first thing that you will have to understand is atoms. So you might have studied about atoms in your school days. So what is atoms? If you long back in history, people used to believe that whatever things that surround us, they are as they are. So stone is a stone, and there's nothing more to it. But around 17th century, 18th century, we had a lot of brilliant people who did lots of experiments. They were experimenting with different things, and one of the guy named Dalton, he was doing some chemical reactions and experiments and stuff like that, and he discovered that you can combine if you bring say if you have a substance A and you have a substance B, and with some definite proportions, say if you have 1 gram of substance A and 2 grams of substance B, and you bring them together, or if you introduce them to a reaction, you can create a separate substance, a substance C. Now, that was really an interesting find. And he also found that if you just change the proportion, so instead of having 2 grams of substance B, if you make it say 4 grams of substance B, then you can have a totally different substance, a substance D. So he figured out that matter is not what it is. If you combine them, or if you bring them in, or give them the proper atmosphere or the temperature or stuff like that, they have the capability to interact with each other and form something new. So that was the first understanding when people started, when people came to know that matter is not what it is, but they are formed of even smaller matters. They can combine with each other to form different substances, and things change all around. So he came up with the first theory called as the Dalton's atomic theory. So he said that every matter or every substance is made up of smaller things or smaller particles called as atoms. He also said that atoms, they are indivisible. You cannot further divide an atom. But when you bring different substances into chemical reactions, these atoms will rearrange themselves, and they can form something new. He also said that atoms in a single element, they are identical. So if you have one element, say in oxygen, the atoms in oxygen will always be the same. They will have the same weight, they will have the same properties, etc. And he also said that atoms of different elements will have different types of atoms. So an atom of oxygen won't be the same as the atom of hydrogen. They'll always be different. And he also said that you can combine these two different atoms of two different elements to form something called as compounds. So for example, oxygen is an element because it has one type of atoms, and hydrogen is another element which has one type of atom called as the hydrogen atoms. But water, it's not an element, it's a compound, because one atom of oxygen and 2 atoms of hydrogen, they combine to form a compound called as water. So that was the first time when that people came up, or the scientific community came up with this idea that things that surround us are made up of smaller thing called as atoms. After Dalton's theory, a lot of experiments happened, a lot of new inventions happened. People found out electricity, the uses of electricity and stuffs. But still people believed that the smallest particle that a matter can be broken into are atoms. That was still the fundamental believing. But still experiments were going on. People knew, if you have a cathode and an anode, and you attach it via a cable or a wire, lights will glow up. They knew all those things, but they didn't knew that cathode was electrically negative and the anode was electrically positive, and it's the attraction between them that causes the light bulbs to glow, things like. They didn't know that. So one of the things that the scientists were experimenting was a thing called as the cathode ray tube. So what a cathode ray tube is nothing but you have a plate which is negatively charged. We will call it as the cathode, and there is another plate. So for them, these are just two different substances or two different elements, and they knew that if they attach these two elements, one is cathode, one is anode, and they knew that if you attach it via a wire or something and you apply a voltage, a ray passes through the cathode to the anode. They knew that, but they didn't know what it was or how, why, the reason why it is happening, etc. So a lot of experiments, or a lot of scientists were experimenting with this, and one of the person called as J.J. Thomson, he was especially interested in understanding what these rays are which pass through the cathode to anode. So what he did was, he made a slight hole in the anode, and he put up a screen in front of it and coated it with phosphor. And what he saw was the rays that were passing through from the cathode to the anode went through this slit and hit the phosphor and the phosphor glue. Now he was very intrigued and he wanted to understand what these rays are. They charged? Do they have mass and all those things? So what he did was, he attached a cathode here. So let me call it as the negative, the cathode, and he attached an anode here, an anode plate here. Let me call it the positive. And then again he did the same experiment, and what he saw was, at this time the ray, instead of directly hitting the plate here, it slightly bent. It had a bend towards the anode. So instead of hitting directly into the phosphor, this time the rays were slightly bent towards the anode. So he knew at that point in time that maybe because of magnetism or something like that, he knew that like charges would repel and unlike charges would attract. Maybe because of magnetism, he knew that. So he understood that whatever is coming out has a charge associated with it, or it has a force associated with it, and that force is opposite of the anode. That's why they are getting attracted. So he came to the conclusion that whatever was coming out has the same charge as the cathode. And he did few more experiments, and he also found out that it also had a mass. Whatever the ray that was coming that the ray was coming out had mass, or it had some weight, but that weight was very less than an atom's weight. So he knew that, or he came to a conclusion that whatever was coming out is not an atom. It's definitely not an atom, but it's a smaller part of an atom, and it is negatively charged. Now that was one of the first times when people knew that atoms are further divisible. It contains something smaller and which has a charge called as the negative charge. But it was not a full concept, because you cannot just say that an atom is fully negatively charged, because everything then in this universe will be negatively charged. You won't have reactions happening. So that didn't make quite sense. So J.J. Thomson said that it had positive charges also, and he came up with a model called as the Plum model, I think, the Plum batter model or something like that. So what he said was, so you will have an atom would look something like this. You will have lots of atoms, and they are inside a proton cloud, or a positive batter. So consider it as a cake, and the positive charges are the cake itself, and the negative charges are, say, the cashews or the plums that you put on top of it. So that model was called as, that was the first model, that was the first time that humans or the scientific community know that the atoms can be further subdivided, and they knew that one of the particles that atom was made up of was electrons, and the model that they came up with was the positive charges is like a batter, and the negative charges or the electrons are like plums on top of it. So this was called as the plum top model or something like that. I don't remember the exact name, but something like that. Now that went on for some time, and during that time or after some time, one of the new elements were found called as uranium. Now uranium had a very special property. It is radioactive. That means that it can decay. The atomic structure will change by itself. It will change from one element to another element and give out things. So they of the scientific community discovered that this uranium element has the property of giving out positive charges, or it has the capability, or when it decays itself, it gives out a positive charge. Now there was a lot of experiments happening because of that. They were experimenting with emitting those positive charges into different several stuffs and doing several experiments. And one of the guy called as Rutherford, he was experimenting with these uranium radioactive stuffs and emitting positive charges all around the places. And one thing he did was he emitted the positive charges to a gold plated, something that was gold plated, and he discovered that, or what he found out was, most of the positive charges went through without any problem. It just went through, but a few of them radiated directly back, just bounced back. Around 80 to 90% of the rays just went through without a problem, and few of them, just a few of them, just bounced directly back. The positive charges directly bounced back to the emitting particle itself. Now he was confused with that, because according to the Plum model, you have the positive charges in a matter. You will have the positive charges everywhere, and the negative or the electrons will be, or the negative charged particles will be on top of it. But this showed that the entire positive, because positive and positive should repel and the opposite should attract, that was not what was happening, because all the positive charges were just going through. And the interesting part, the few ones that came back, that was the interesting part. So what he figured out was that in this substance, or in this gold plate, the positive charges, because the positive charges were concentrated on certain places, not in the entire space. The entire space was almost vacuum. That is why all the positive charges were going through, and the positive charges were concentrated on certain places. So that was the beginning of disapproving J.J. Thomson's model of atom. And what Rutherford proposed was, instead of the positive charges being all across the place, it will be concentrated in the center, the positive charges, and the electrons will be orbiting this positive charge. And the electrons, so these are the electrons, and they will be orbiting this positive charge. And this is the Rutherford's model of atoms, in which you have the positive charges in the center, they are concentrated in the center, and which are positively charged, and the negative charges, which are the electrons, will be orbiting around this positive charged nucleus. So this was Rutherford's atoms model. Now many things happened after that. People also discovered neutrons. They also knew that instead of protons, there was also an element called as neutrons, and the neutrons had a negative, or they had a neutral charge. So positive charges were the protons, negative charges were the neutrons, and the electrons were circling around it. This was the Rutherford's model. Okay, so let's have a look back to what we have learned till now. So we knew that Dalton was the first person who said that matter can be further subdivided into smaller particles called as atoms, and J.J. Thomson discovered that the atoms can further be subdivided into electrons and protons, and they are arranged in a plum cake manner, where the protons are the plums, are the batter, and the electrons are the plums sprinkled on top of it. That's when Rutherford came in. After that, Rutherford came in and he said that that's not how it is. So in an atomic structure, you will have the protons in the center, and you will have the electrons which will be revolving around them. So basically, till now we know that an atomic structure will have three fundamental particles in it. You will have an electron, you will have a proton, and you have something called as neutrons. They are also similar particles, but they don't have any charge associated with it, so they are neutrally charged. So let me also give a value to the charges they have. So let me give a value of -1 to the electron, and let me give it +1 to the protons, and these are 0. So when people started knowing the atomic structure, they started noting it down. They started discovering what are the different atomic structure of the different elements that we see around. So they knew that hydrogen atom, the atomic structure of hydrogen was 1 proton and 1 electron. Then they discovered helium, which had 2 protons and 2 electrons. So they started noting it down into a table, and that's the table what we call it as the periodic table. So the periodic table will be something like, so it's arranged in such a way that it tells you the first element will be hydrogen. So that is because it has 1 proton. So it has 1 proton, so that will be your first element, and the second element will be helium, I think helium. So that is because it has 2 protons. Then you have 3, the third one is I think lithium, I think, so it has 3, and I think beryllium, which is 4. So it goes on like this. So what this number is the number of protons, and that's called as the atomic mass. So atomic mass is nothing but the number of protons in that atomic structure, and any atom which is electrically neutral, which in most cases they are electrically neutral, the number of protons will be equal to the number of electrons. So if you look at the periodic table, and you can find out the atomic structure of any element. All the elements that we know till now, that has been discovered till now in this universe, will be available in your periodic table. So now I know that lithium has 3 protons, so I know that it has 3 electrons. The number of neutrons won't be much matter because they are electrically neutral, so the chemical properties wouldn't matter much in knowing what the value of that neutron, or what is the number of neutrons in that's my IRC going crazy. Yeah, so that's the periodic table. So looking at the periodic table, you can figure out what are the different elements and what is their atomic structure, and this will be really useful because horizontally it's the number of protons that each elements have, and if you look at vertically, it will tell you, so all the elements that are aligned vertically will have similar chemical properties. So for example, everything here are inert gases, so they will react in the same way that the first one will. Similarly, whatever is in your first row, they are very reactive to oxygen. So whatever is the hydrogen, lithium, or whatever comes down, all of them will have the same chemical properties. They will react with oxygen in the same way. And somewhere in the middle you have the metals. So just by looking at the periodic table, you know what the atomic structure of an element is, what are the different elements, and how will they chemically react, or what are the chemical properties of those particular elements. So that's it, and in the next part I will be introducing you to the Niels Bohr atom of Niels Bohr's model of atom. I'll be also introducing you to the concept of lights and the latest one, or which is the quantum model of the atomic structure. I'll also introduce you guys to the latest, which is the quantum model of the atomic structure. Thanks.